rest of those real quick. Yes, ma'am. Yeah, you just check upstairs. Now you gotta run all the way back upstairs. All right. So here we go. Tell me.
I probably remember
Say.
6.
6. Thank you. What's the issue with this?
Okay, so I got that. I got
You got the numbers I got?
Yeah.
So it's just a matter of just plotting the points incorrectly. That's why I was telling some of the kids in the other class, if the points don't lie on a line, then you know you made a mistake. That's why you graph 3 points and not 2. All right? So you just have to verify or double check. All right? Anybody else have a question with last night? Go. Come on.
on number 4.
All right, let's look at number 4. What's wrong?
I just wasn't sure that I got the right answer because I did like the -2
Well, now you're looking. Tell me, is that right?
I got the same thing. I got -3 0. So,
No, because a negative times a negative is a what? See the negative right here. So that means if I plug in a negative, I'm going to get a what? That's right.
Oh, okay.
Right?
Yeah, and then my other question was on number 8.
Okay, so let's look at number 8.
So for this one, I plotted the points and I checked it again, but I still didn't like.
We'll double check to see if your points are correct.
Yeah, I have the correct.
Okay, so then plot -1, -7. Usually the mistake is made on 0, -1.
So.
You go 0, then you go down 1.
Oh, I see what I did.
Right. Yes, sir.
For the first one.
Oh, I see what I did.
You good? Anybody else on last night's homework that want me to double check something? Because I did forget to post
Sorry, I
it.
messed up. How did you get
Okay.
-7 there?
If you plug -1 in, right?
Mhm.
So it's going to be 6 times -1 minus 1,
Oh, yes.
right?
Will you post the answers with the...
Yeah, I'll post them. I'll post them. All right, for sure. Yes.
I just have a general question. So let's say it's any number x, let's say like 12x, you would do -1, 0, 1.
Yes. All right. It's just easier, right? I mean, you can put any 2 numbers or any 3 numbers that you want, but the smaller the better. Yes.
So for like that one, it goes like, for the y, as you go down, it goes like +6 for each number.
That's right.
Would it like have that pattern for everyone? Like
That's
go
exactly right. That's what we're going to talk about today. Very good observation. The only thing is, look at the fraction one. The fraction one isn't that same. Watch. Very, very good question. How much should I go up to here? Or how much should I go up here? Watch this. How much should I go here? That's that number. It's really cool. All right, that's what we're going to learn today. All right, it's very good. Good, good. Okay, so again, just give yourself a big check on this one. I'll put everybody in as good. All right, I think it was kind of easy. Now, today, you got to put everything away, close your iPads, and I just want you to pay attention. And then we're going to, today's one of the most important days because we're talking about slopes, all right? Slope, all right? But before we talk about slope, I need to kind of show you exactly something. To me, this is going to represent like a line, and this represents a line. So what makes the lines different? What?
They're angles.
They're angles. Everybody says that. That's exactly correct. Later on, I think it's pre-calculus to learn about angles of inclination. All right? But right now, there's something even better than the angles. All right? What is it? Actually, this line is different than this line because they have different slopes. All right, and the slope is just how you get from one point to the other point. All right, a lot of times in math we call it the rise over the run. All right, sometimes we call it change in y over change in x. All right, so again, one slope is positive and one slope is negative in this example. Which one do you think is the positive slope? Which one?
Your right. Or your left.
All right. Now, what do you think? Now listen, think about it this way. You always read numbers from left to right. So if you always read numbers from left to right, which one is positive now for sure? The red is positive. All right. Now I tell kids, come on, you got to be paying attention now. There's nothing more important. You talk about slopes all the way through college. All right. There's whole calculus is all about slopes. All right. There's a whole branch of math just on slopes. All right. So this right here is a positive slope. This right here is a what?
Negative.
We say this is positive because we're going up the mountain, and we say we're going what? Down the mountain, right? Now, we had to start somewhere, so this right here is the starting spot. That slope right there is probably what? What is that slope? Slope is a number. Zero slope, thank you. So any horizontal line has a slope that is what?
Zero.
Now my slope is getting what? Bigger, right? It's getting bigger, steeper, right? Now that's a what type of slope? But now this is a what? Negative slope. All right. Now all of a sudden we're going to go think about skiing on a mountain. Is that pretty safe? Is that pretty safe?
Yeah.
Not so safe, right? Now, what would happen if I told you to go ski on this mountain? You're probably what? You're probably going to die, right? Because that is called what? That's called free fall, right? You'd be free falling. That would not be skiing. You'd be jumping off the side of the mountain cliff. That's exactly right. Right? So this, we say, has no slope. That's how I remember it. If it's vertical, there is no slope. All right? As soon as a slope is created, you can now ski off of it. Right? So you would be going into the mountain. Now, some of you would be going so fast you'd end up falling and tumbling down. That's what happens to those extreme skiers or whatever they call them, right? So again, here's importance. Slope right here is what? Zero. All right, now this slope is a positive or negative?
Positive.
And this slope is?
Negative.
All right, now I'm going to try to trick you. Which slope is bigger? Is this a positive or negative?
Negative.
And this right here is a what? So which one's bigger?
Positive.
Right, so listen, this is the kind of thing I want you to remember. Slope has no value. All right, so for example, if you're skiing down a mountain, you don't say, well, that's a negative slope and that's a positive slope, right? So the positive slope isn't always bigger than the negative slope. Does that make sense? So for example, that's very negative. Do you agree? So you would say that slope is greater than what? Even though this slope over here is what?
Positive.
And this slope is what?
Negative.
So do you understand what I'm saying? So we kind of say it's slope, when you're comparing slopes, it's kind of like an absolute value. All right? Slope is always kind of a positive thing. All right? Now, the most important thing is to remember this is what we're starting at. 0. And then it goes extremely positive, and now it's what?
No slope.
No slope. All right, if we obviously go the other direction, we're going negative, extremely negative, no slope. Is everybody okay with that? All right.
Extremely.
No, that's just a way of describing it. Okay. Now you're still just going to listen. I don't really care about writing anything down. Most important is to just concentrate on what I'm writing up here on the board. All right, because there's lots of different names for slope. I always said, why don't they just call it the same thing and it would be much easier. But when you take standardized tests, they don't ever really say slope. All right, there's different ways of describing it. All right, so in this case, slope can be referred to as a rate of change. You don't have to write it down. I know all you guys want to write it down, but it's not necessary right this moment. Slope is a rate of change. All right? Now, what makes that slope? And here's what I mean, all right, by the rate of change. All right, I'm going from one point to another point. That's the rate of change. All right, so what did I do to get from one place to the other? I went up a certain amount, and then I went what? And then I went over a certain amount. All right, that's referred to as its slope. All right, so in this case, this is referred to as the rise, and this is referred to as the what? The run. So another thing we can talk about when someone says to you about the, when somebody says another definition or what they might be talking about is slope is the same as what? The rise over the run. Okay? Now let's just say this point right here. All right, let's say this point right here just happened to be 2, 5. And let's say this point over here was, let's say, for example, 5. Let's say it was 9. All right. What is the rise? What was the rise?
2,
2, 5. What's the rise?
4.
4. What do you think the rise is?
5 and 9.
5 and 9. What's the rise?
3.
3.
3 over 2.
What's the rise?
3.
3. What's the rise? Rise?
3.
3. Don't change your mind just because there's a bunch of people saying 3s. All right, you're supposed to learn to believe in what you think. All right, it's better to think about something to be wrong than tell me what someone else is saying. No one cares what anybody else is saying. What do you think?
4.
4.
I don't know.
5.
I changed it
4. 4. Okay, I'm not saying what's right or wrong, but we're talking about what is the rise. So here we go. This is my rise, right? So how much should I go up? When you think about going up, what are you talking about? The y values. Everybody agree? So how much should I go up?
4.
Because I started at what?
5.
And I went to
9.
9. So my rise is what? 4. Now, rise, I always tell kids, if I was making up math, I would have done the x. I would have done the run over the rise. Because we plot points what first? X, and then we do the what? Y. Now they're telling me to do the what first, and then they're going to tell me to do the what? X, which doesn't make sense to me. Everybody agree with me? So you have to remember, when you plot points, you do X and then Y. When you're doing slope, you do what? Y and then what? X. So what is the run here, guys? The run would be 3. Right? The run would be 3 because we went from, thank you, from 2 to what? To 5. All right? So we moved on the Y and then we moved on the X. So tell me.
I just have a question.
Sure.
Why did you stop the rise where you did? Like, instead of going like all the way up so that it's equal to where it was?
Okay, that's a very good question. I'm going to get to that in a minute. Very important question, actually. All right, very, very good. All right, so another way you're going to hear someone talk about rise over run is it's referred to as delta y over delta x. Delta in science just means change. All right, so change. All right, now how do we find the change? How did I know the answer was 4? Using 9 and 5, what did we do? That's exactly right. We just subtracted. So delta y is abbreviated because I don't feel like writing y sub 2 minus y sub 1. Now what does 2 and the 1 represent? The 2 different what?
Points.
2 different points. Right? In order to find the slope, you have to have 2 different points. So y2 is the second point, and y1 is the first point. And so delta x, who wants to tell me what the denominator for delta x would be? Tell me.
Would it be x2 minus x1?
That is correct. x2 minus x1. That's exactly correct. So that's the formal kind of formula that we use when we want to find the slope given 2 points. All right? Finding the slope given 2 points is y2 minus y1 over x2 minus x1. Although you don't have to do that formula. All right? Now, Hannah mentioned something super important. All right? What did we say the slope of this line was? We said the slope of this line is 4 over 3, right? So now, I'm going to blow this up a little bit. I'm going to ask you a question. What is the slope if I went here and here? Somebody tell me what they think the slope would be. Exactly correct. What if I did from here, if I came up here, and I did to here? What's the slope going to be? 4 over 3, right? It might not be 4 over 3. It might actually be what? 8 over 6. But it would still reduce to what? Right? It might be 2 over 1.5. But that's still going to be what? 4 over 3. Everybody agree with that? I know, M is the weird. This is something that was bothering me also. M is the letter they chose to represent what? Slope. I have no idea. I have no idea. All right, M is the slope. All right, for whatever reason. All right. Just like B is going to be considered the y-intercept. I don't know why they chose B for that either, but they did. All right, so that's just the letter for slope. So I need you to remember that. M is referred to as the slope. Yes?
So is it like 4 over 3 is equal to 8 over 6?
That's exactly right.
Twice the amount.
Well, I mean, let me give you a good example for this. I'm gonna make my own little problem up real quick so I can show you something that's really nice. All right, I'm gonna do this real quick and give you a better example. All right. So just because you asked, I'm gonna show you. Uh-oh, maybe I will. All right, so here we go. All right, I'm gonna make my own little graph here, and then you can show me something. Hopefully you'll understand what I'm saying. All right, so here's graph paper. All right, now I'm gonna draw a line from here. I'm gonna do an easy one. There's my line. Now, can anybody look at that and tell me what the slope is? Positive what, though? Somebody take a stab at it. Positive what? Good. 3 over 1. What do you think? I think you should know. I think everybody should know. What?
0, 1.
0, 1? What? What do you think? That's all right. It's okay. Well, first of all, we should be able to look at that and say, is it positive or negative?
It's positive.
Definitely positive because we're going up the mountain. What do you think?
0.
0, 1? 0 over 1. 0 means that it didn't go up at all. Say it again. What do you think?
1 over 0. 10 over 5. 3 over 2.
You got it backwards.
Oh.
Say it again.
10 over 5.
But what's 10 over 5?
Positive. It's like.
Tell me. Shh. No. Think about what I just said. Stop. I asked you, what is 10 over 5? What does that reduce to? Remember, over means divide.
Oh.
10 divided by 5.
So 2 over 1.
2. The slope is 2. Actually, it's 2 over 1. All right, now here's what I want to show you now. So again, please now watch so you can understand. Again, very important. All right, I think it's easy, but a lot of people make this mistake. All right, does it matter what 2 points we pick? We're going to find out. From here, I went up what? 2 and over what? 1. Somebody went from here, they went all the way up to here and all the way over to here. What is that ratio?
10.
Say it. 2 to 1.
So any single.
So if I pick this point right here and I go from here to here, what's it going to be? What's the slope? 2 over 1. All right. If I go from, now watch, if I pick this point right here and I go up here and I go over here, what's that ratio going to be? 2 over 1. All right. It doesn't matter what points you select. As long as you do the math correct, you'll always reduce the fraction down to 2 over 1 in this case. What?
How do you know, like, I get how you got 2 and 1 for the first time. How did you get 2 and 1 all together?
Because we counted and we reduced the fraction. That's all we did. Sam, what?
I don't really understand how you got 2 over 1.
How much did we go up, Sam?
Oh, you reduced.
Come on. How much did I go up, Sam? And I went over what? You see what I'm saying now, right? That's all it is. Here, like he said earlier, which I was happy with, he said 10 over 5. That's exactly correct. What does 10 over 5 reduce to? Doesn't matter. Doesn't matter. This over here, all of these over here are called delta y's. These up here are called what? Delta x's. And slope is defined as delta y over delta x. As long as you have a line, the slope will always be what? The same. It doesn't matter what 2 points you pick. Tell me.
So you could go like 3 up and then go over and you'd still get 2 over 1.
That's exactly right. If I went up 3, then I would go over 1.5. Because 3 over 1.5 is 2. What?
So it's delta y because the delta change. And
Yes.
You could like change the y.
Right. That's what that means. The change from y is y2 minus y1. And the change in x is just x2 minus x1. All right? Does anybody have any questions? All right, so let's see if I made any sense, guys. All right, here we go. So let's try this again. Look up now and try to figure it out before I get done.
The line doesn't have to go.
I just want to know what the slope is. What do you think? What?
Negative 3 over 2. Wait, negative 1 over 3 over 2.
Negative 1 over negative 1.
Negative 3 over 2?
1.25 over 1.
Now you know what.
Well, it was 2.5.
But how are you getting? I'm not understanding how you got 2.5. Because let me explain to you. Listen, that's not. You're not wrong. You're not wrong. I'm just saying I would never use a decimal on a graph because I don't know if it's exactly the right decimal. You see what I'm saying? So every single time I try to find a point that's exactly on x and a y. Okay. What did you think? Negative 3 over 2. Is it positive or negative?
Oh, 3 over 2.
Yeah, negative 3 over 2.
Yeah.
Right? You forgot the negative.
How do you know?
Right.
How do you know?
Okay, so let's find out. So what I did here, watch, guys. I think this is what's important now. I'm going to take a dot right here, and I'm going to put it on the graph for you. Now, would it be smart to put it right there? That wouldn't make sense. Would it be smart to put it, let's say, right here?
No.
Because I don't know what that number is. Right? So we have to find a number that looks pretty good. That looks pretty good to me right there. Does that make sense? Right? And then what we're going to do is I got to find another number. All right? So I'm just grabbing my point right here. Right? I'm moving it up or down. Right? That would be a good point right there. Right? Another point could be right there. Right? It doesn't matter which point I select. All right? It makes no difference. The ratio is going to be the same. The numbers can be different, but the ratios will be what? The same. Now, what does that mean? That means like 1/2 is the same as what fraction? Say it. 2/4. Is the ratio the same? Is the ratio the same? Yes, the ratio is the same. The slope is the same. Do me a favor. Listen. These bottles are killing me. Why don't you go home and listen to the video, and you can hear yourself playing and knocking on that bottle all period long. No more. People are concentrating. All right? So the ratio is the same. The numbers might be what? Different. All right? But what's going to happen to the fraction? It will reduce down to something that is what? The same. So it doesn't matter what two you pick. Right? Now, notice I said it could be that point right there, or it could be this point right here. So what I'm saying is, what is delta y right now? Somebody tell me who's been paying attention. What is that delta y? Be careful. Yes, those guys have been paying attention. We're going what? Down. So that's negative. And then I'm going to go to the right. How many?
2.
So delta y is what? -3. Delta x is +2. Hold on a minute. I'm going to get to you. Next step. I always have kids who say, well, what if I don't want to go that direction? What if I want to start on this point and I go up? How much would I be going up? 3. Now, you got to be careful. How much am I going to the left? -2. So in this case, delta y is 3 and delta x is -2. Again, if I do 3 over -2 or -3 over 2, is there a difference? No, there's no difference. That's why it doesn't matter where the negative goes. If it's in the numerator or in the denominator. Quickly.
So if you're going like to the left or down, it's always negative.
Guys, put your calculators down. The same thing. You go and listen to the video, and I hear calculators being knocked around and, you know, water bottles being knocked around. People are concentrating. It's distracting. All right? Tell me again. Sorry.
So if you're going like to the left or down, it's always negative.
Well, that's brilliant, right? And these are the types of things that we want to say. That should be where people make their mistakes. Sometimes I always tell kids start at the left and read to the right. That way you're consistent. But some kids are stubborn and they want to go from up and to the left. And then they make a mistake because they forget going to the left is negative. Going down is the easier one. All right? What now?
So, like, if one number or fraction is negative, like, basically the whole fraction is then, like, you put in the
Brilliant. One negative makes it negative.
Well, one of the usually be negative.
Right. Listen, we're trying to avoid just generalizations. I want you to just know the rules. If you know the rules, you can play the game. Right? It's very simple. Very, very simple.
So basically, it's like, that's a good way to tell, like, if it's a negative slope, it would be a negative and a positive slope. It won't be.
Well, no. The easy way to tell if something's positive or negative is look at the line. If you're going up the mountain, it's what? Positive. If you're going down the mountain, it's what? Negative. So if I pick 2 points, for example, from here to here, I know the slope is what? Because I'm going up. If I say from here to here, now I know the slope is what? Because I'm going what? Down.
So when you're going to the right, it's negative.
No.
Not
No.
necessarily.
Listen.
When it's going
Listen.
down.
You're right. And here's what I want to show you. And listen, don't. It's okay. Listen to me. I know you're thinking about it, so it's all good, right? That's why I don't like generalizations. Watch. I love my iPad because of this reason. That is what? This is what?
0.
0. This is what?
Negative.
This is
No slope.
undefined or no slope. This now is back to what? Positive, right? And it just, that's why I just think there's no, I try not to tell kids this is always the way it is, because in math, generally there's a what? Exception to the rule. All right? It's just looking at the 2 points. No matter what, you look at the 2 points. To me, I'm going what? Down, right? Because I've learned to read numbers from left to right. So I always start with this point, and I'm going to this point. I'm going down. Here, there's no other way around it. I'm going what? Up. So that's positive and negative. All right, is everybody with me now? All right, I think we're doing pretty good. What time does the bell ring?
7 minutes.
We got 10 minutes? Okay, so now we can get some work done. All right, so do me a favor, pull out a sheet of paper real quick. All right, I'm going to change the homework for tonight. For those of you guys whose calculator did not come in, we're probably going to hold off on the calculator until Monday, but still bring it. All right, still bring it. I might just show you a few things on the calculator. All right, some people still don't have their calculators. They're coming in the mail, so don't worry about it. All right. All right, that was an excellent job, guys. Excellent job for listening. Now, what I want to do is don't write the assignment on the top because I'm going to change it, all right? Just put section 3-3. That's all you have to do, section 3-3. And then tomorrow we'll finish things up. Now, if I've done a great job, which I think I have, pat myself on the back for that. All right. I want everybody write down number 1, m equals, let's see how good I did. M equals, what is the slope for number 1? Raise your hand when you got it. Tell me.
3/4.
Ooh, I like the confidence. 3/4. Somebody else. Why is it 4/3?
Oh, because I did the x.
That's what everybody does when they're first. It's called a rookie mistake. All right? Rookies do delta x over delta y instead of delta y over delta x. Perfect mistake to start out with. All right? So everybody should be able to look at that and just say it is 4/3. Anybody completely lost? If you're completely lost, I'm not sure if you listened very well. Everybody okay? Stop for what? What? I'm the one talking. You should be looking at me. That's who's talking if you're confused. All right? All right. Now let's see how great I am. Look at number 2. Somebody who's thinking.
Oh.
Is it?
The 9, negative 9 over.
Well, what's negative 9/3? Come on, don't give up on yourself. It doesn't matter if it's right or it's wrong. You're thinking. That's what I'm telling you. You'll be happy. You're learning to think, right? Go.
5 over -3.
What?
No, -3.
What?
-3.5.
Fractions. We deal with fractions. Tell us.
8/2.
Now, who would say 8/2?
I said.
No, I don't. I'm kidding. So what? So it's like saying 2/4. I would never say 2/4 because 2/4 is the same as
A half.
a half. So say what you said again originally.
I said 8/2.
So that's the same as
4.
right, right.
4/1.
There we go. Is it 4/1? Let's see. He is 100% correct. We went from 10 to 18, which is how many? 8. And then I went from 7 to 9, which is 2, which is how he got 8/2. But again, we just don't say 8/2. We say what? I'm going to show you. We just say I was hoping somebody would say 4/1, but we really don't even say 4/1.
4.
We just say 4. The slope is 4. All right. Now, how do I know it's 4? Because I counted from one y to the other y and from one x to the other x. Now, some of you, does it matter what points you pick?
No.
No, because some of you should be able to look at that and say, well, I didn't pick those 2 points.
But I got the same answer.
But I got the same answer. I rest my case. Even Morty got that. All right? All right? So, let's just say I don't like that. I'm going to be crazy. I'm going to go from -6 to 26. What's that?
That's like
32.
No, it's not like 32. It is what?
32 over 8.
And then from 3 to 11.
8. I said
Yeah, and this is why we don't say 32 over 8. We just say 4. 32 divided by 8 is 4. So again, let me make myself perfectly clear. You always reduce the fractions. Don't you agree? That's pretty easy.
Yeah.
All right. So now, listen to me. I don't really care about number 3. I don't really even care about 4 and 5. Okay, here's the heart of the problems right here, guys. 6 through 11. I'm going to give you 2 points, and because we are brilliant, we can figure out what the slope is. All right, so I'm going to look at number 6. Now, listen, again, I want you to write down number 6, m equals, I need you to write the formula. M is equal to y2 minus y1 over x2 minus x1. What is y2 minus y1?
Y1.
Yes, what is the number?
1.
No, it's
What?
6.
No, it's
6. Somebody made a rookie mistake. And then,
1.
It's 1.
Oh,
So it's 6.
now before you raise and ask your hand, ask me a bunch of questions, I want you to look up there at those points and figure out, okay, he got 6. I have no idea how he got a 6, but I'm looking at 4 numbers, and the only combination that's going to give me a 6 is if I do what?
9 minus
That's how you learn. Right, you don't have to ask me that. You can look up on the board and say there's 4 numbers. How did I get 6? And make some general observation. Then there's another 2 numbers that are going to give me 1. All right, remember, slope, delta y over delta x. That's what we got. Change from 9 to 3. Now, some of you are going, well, can I do 3 minus 9? And the answer is yes. Do 3 minus 9, and you would get what? And then if you did 5 minus 6, you would get, and that's, there you go, still a positive 6. So it doesn't matter. So it doesn't matter. All right, so now I want it quiet now. I'm going to ask somebody a question, and I'm going to ask for the slope for number 8. Shh. Everybody give you 20 seconds. When we're done with those 20 seconds, you got to be careful because Jude's going to jump right in here and tell me the answer. Thank you. I appreciate you volunteering. Give it a shot. It's okay. It's okay. If you're not sure, it's okay too. Or remember, it's always what? What's the second y value? One number 6 or number 8. Sorry. What's the second y value? 3. Come on, come on. Don't be nervous. 3. Now minus what's the other y value? There you go. Look at that. And you just do that, right? But of course, we never say what? Minus a negative. We would just say what? Shh. I'm helping. What is it? Right. So you would just say 3 plus 2 over. Now look at the x's. Now, listen to me. You made a good rookie mistake. All right, but watch. If I go this direction, I have to also go this direction. You see what I'm saying? That's a good mistake again, guys. You have to go in the same direction. As long as you go in the same direction, you always get the right answer. So that was what again? You're exactly right. So your slope is 5 over 2. Come on, that's not that hard. It's not that hard at all.
Did you write 2 and 1/2?
No, if I was going to write 2 1/2, guess what? I would have written 2 1/2. When you get in advanced math, we don't do mixed. We always do what? Improper. We don't really ever do decimals either.
Only if it's a whole number?
Only if it's a whole number. That is correct. You're up. I want you to tell me what the slope is for number 10. So what's delta y?
Delta y 2 minus y1.
Good. Perfect. What is that?
0.
Rookie mistake. It's delta y, right?
Oh.
So you were right. That 0 goes where, though? The 0 goes on the bottom. What goes on the top? Beautiful. -3. Now, if you have 0 on the bottom, you cannot divide by 0. You cannot divide by 0. That is what? That is undefined, which means it's a vertical line. Now, do you guys know why you can't divide by 0? A lot of people say you can't divide by 0, and people are like, well, I don't even know why. All right, because the calculator says you can't divide by 0. I like that, all right? But now, here's the mathematical reason why you can't divide by 0. Hold on. You guys are telling me, did I do something wrong? The end, right? Is that the bell?
Yeah.
All right, so we'll finish up tomorrow, guys. No homework. Good job. I promise. -3 minus -3. Right? Oh. I know. Rookie mistake. 4 minus 6.